Welcome to Fox's bit of a stream recording tutorial. This tutorial is optimized for Intel processors with an HD 4600 onboard graphics adapter or better in a dual stream setup using 2 instances of OBS. For starters, we need to make sure your HD 4600 is enabled. To do that, boot into your BIOS. You're looking for a Northbridge or chipset configuration depending on your motherboard manufacturer. For ASRock, we're going for the chipset configuration and looking for a setting called Primary Graphics Adapter. This should be set to PCI Express to ensure your GPU is the default. Next, we set your iGPU multi-monitor to Enabled to allow video out on your HD 4600. Save your settings, reboot into Windows. Plug your capture card into the video out on your motherboard, and then check to make sure your display settings shows the monitor. You may need to check with your motherboard manufacturer for the latest Intel graphic drivers for your setup. Next, make sure it's set to render 1920 by 1080. This will not require the use of a monitor output, and it should be maintained primarily on your streaming machine through your capture card. On your gaming system's OBS settings, right-click the preview and select Full Screen Projector and send it to the display based on your Intel monitor's ID. In this case, monitor 4 is display ID 3 as OBX index starts at 0. Because our scene is capturing our main monitor, it should look like an exact clone. I'm going to right-click and close this preview so we can move OBS to our live control monitor. This will allow us to make modifications without ever closing the preview. Now we need to access OBS settings, or more specifically, our recording output settings. For the Intel GPU, we select the QuickSync H.264 encoder, target quality, high profile, keyframe interval of 2 seconds for Twitch, rate control CQP, and all subsequent related options to 20. The smaller this number, the higher the quality, and the more intense the resource usage. Too low of a number here will result in encoder overloading when there's a lot of activity on screen. Make sure you're recording to a capable directory, preferably somewhere not on the disk drive containing the operating system or your game. An SSD can bypass either of these recommendations. If you choose to record on a shared drive or another machine, you'll need a more advanced dual Ethernet setup to reduce latencies. It is not recommended. For testing purposes, we're going to use Escape from Tarkov as it contains a lot of foliage that can mess with bitrate limited streams. Here, we see the onboard GPU at near lossless quality. The raw recording peaks around 110 megabits per second, but YouTube limits us to 25 megabits per second, which means you'll see a few anomalies, but it's still very high quality. Neither of these recordings place any strain on the resources used on playing Escape from Tarkov. The game machine is using an R9 390 with an i7 4790K, while the streaming machine is running through an Elgato HD60 Pro. Now we swap over to what our stream viewers would be able to see, supposing there are no frames lost in the stream servers we're connecting to in conversions. The specifics of this process will have to wait for another day. Seeing them side by side should give you a clear idea of the quality between the videos. Our gaming feed has a 0.2 gamma correction applied, something the capture card can't capture. This means that you can set gamma differently for the two videos without any conflicts.